The process of iterating through maps is a little bit different than going through sequences or sets. In some ways, they have aspects that are like the sets, uh, in that when you go through them, order often doesn't matter. And for these small examples, we got basically the normal order. I could make a bigger map by doing something interesting. I could take a range like 1 to 100, and then I could map that into a tuple. So let's do I dot toString to I. So this will be, now if I just do that there, I get a sequence of tuples. But if you have a sequence of tuples, you can call toMap. If you call toMap and the thing that you're calling on isn't a tuple, well, it doesn't work. But if it is, then you have this. And you can see here the numbers are all over the place. Okay, so order is not preserved, much like in sets. There are specific types of maps that will do some order preservation, but in general, you should assume that maps do not preserve order. And if you run through these, you will get them in the order they printed out. But there's an interesting thing here. So what should I call this? I'll call it T because I know what it's going to be. But I want to run through this. This is res 45. And how about I just take the first 5? And I want to print line those. I actually don't want to print out 100 things. I want to note something here. Note that when I iterate through these, every element is a tuple. And so I don't get the key or the value, I get both the key and the value. This is actually nice for for loops. Using for loops on maps is handy because I can pull out apart the key and the value there. And do something like that. Okay, so I can use the pattern matching capability of a for loop. If I use something like a map or a filter though, so let's say that I wanted to map all of these. So res 45 dot map. Well, the argument to the function is actually, once again, a tuple. So I have two values in there. I have the key and the value. And we could do something interesting here. We could return a new tuple. So, and this is worth looking at. If I do a map and I return a new tuple, and I'm going to do t dot underscore 1 times 2, arrow t dot underscore 2 times 2. Remember, to get things out of tuples, you use underscore 1 to get the first element, underscore 2 to get the second element, etc. Since these are all two tuples, those are the only two that we have. And the reason this one's kind of fun is because multiplication on a string actually kind of repeats the string, and whereas on an int it actually multiplies. So now these things look a lot different than what they had before. And this did give me back a map. So an interesting question would be, well, what happens if I didn't do that? What happens if I just gave back a single value? Well, I can't have a map. Okay, to build the map I have to have a bunch of tuples. So when I run through it I make the map give me back just a single value instead of a tuple, I don't get back a map, I get an iterable. And in this case the iterable happens to be a list. So it just gives me a list of all the things that I calculated, but I no longer have a map for this. You can also do things like filter. So instead of mapping this, we could filter it. And I could keep only the things where the value is less than, say, 5. And that should be a much smaller map. So this is our original map of string to int, where it was just the string value and the int value for each one, but I only keep the ones that have a value that's less than 5. If I had wanted to filter on the keys instead, now this is going to be a much more interesting result. I have a lot more values here, and the reason is because this comparison is on strings, and 45 as a string, because the character 4 comes before the character 5, 45 comes before it. So you can see that when you use things like map and filter, you have to be cognizant of the fact that the function is getting a tuple. So a lot of times you're going to use the underscore 1 and the underscore 2, and because that syntax is kind of ugly, when you're going through maps, it's often nice to use a for comprehension and then have the pattern matching so you can actually pull the contents of the tuple out in a nice way.